Now, let's see the chapter 2, which is the photographic remote sensing. So as we know, remote sensing is the sensing or understanding from the distance, which can be done with the help of photographs, which are generated especially in the air. And these photographs are uh, taken from different platforms. There are different platforms, there are different photographic sensors, there are film detectors. So all this is related to photographic remote sensing. So what we need to know about the photograph is what are the types of photograph? Are they vertical photographs, oblique photograph, or stereo photograph? Such type of remote sensing was very popular before the satellite data was not so uh, good. I mean, nowadays we have more satellites, more satellite data, so we are using less photographic remote sensing. And now we are using the satellite data, and satellite data is also giving us good resolution, like maybe uh, higher resolution. Higher means less pixel size, maybe 10 centimeter up to 500 meter or 1000 meter. So there are different satellites giving us very good satellite data on the images. But here we are talking photographic remote sensing, which was very popular earlier, but it is popular when we talk about EU uh, AV, unmanned aerial vehicles, like drones. So drones, remote based on drones also comes in this category. And what we need to know is we here also we need to know the electromagnetic spectrum, because the energy is being used is visible light or near infrared, and the panchromatic uh, is the part of the energy which is full. I mean the visible. They take whole visible part. Entire visible spectrum means blue, green, and red part of the visible spectrum. And multispectral means they give us multi bands. Blue will be a single band, then green, then red, then infrared. Such type of images are called multispectral. Means spectral here is indicating the wavelength. So data is into the bands of different wavelength. Blue has its own wavelength, that is around 0.425 micrometer, and then green 0.5 to 0.6 micrometer, and then red 0.6 to 0.7, and then near infrared, which is not the visible but is near infrared. And then we need to know the reflectance properties, and then we need to know photographic geometries. So all these are the principles which we should know uh, uh, before we do photographic remote sensing. There are different techniques: aerial photography, stereo photography, multispectral photography. And then what we need to know for image interpretation, here for visual interpretation we need to know the tone, color, the texture, shape, size, pattern, shadow. Okay, when you will read all, here examples are also given. And then we can without digitization also we can do some analysis using the stereo pairs with stereoscopes. Okay, it gives us a sense of elevation, slope, and terrain feature. And then we can do the manual digitization also with the help of photographs like river and roads. There are some advantages. There is a high spatial resolution, cost effective, easy of use, and versatility. There are certain limitations. Of course, it's very costly. It's not and temporal, not like uh, this is one time you are taking the photograph, then again as per your need you have to take another flight. Then it's not continuous like satellite remote sensing. There is data storage is also, you need to know, you need to have the data storage. And then there is a geometric distortion also. So these are the limitations. There are applications same in the agriculture, forestry, urban planning, and disaster management, archaeology. So okay, and all these things uh, I will suggest you to read, and uh, you can have an idea that how photographic remote sensing is helping for the students of geography, because the core objective of geography is to study the surface of the earth, the aerial differentiation on the surface of the earth, which can be achieved with the help of photographic remote sensing. Now we'll move to the next chapter.